Hello, and welcome to what will be the first of many videos that we're going to have now for our online lessons. We're doing science this way for the time being thanks to these little viruses here. I don't know when we'll be back together, but I hope it will be sooner than later. I know this virus is interrupting our lives in a lot of ways. We can't just go and hang out with friends like we used to. Even I can't go to Disneyland anymore, so we have to just make the best of our situation here. For instance, I'm wearing my mouse ears as I create and record this presentation. Like I said, this is all about making the best of our situation. In the meanwhile, it's time to get to work. Make sure that you have access to OneNote and the Plate Motion Sim for today's work. Remember, you can pause the video at any time, like right now. You can pause to get your things ready. We'll wait. Ready? Okay. So this week we're going to talk about plate boundaries. Remember that plate boundaries are where two plates that make up the Earth's outer layer meet up. When we last talked, we figured that there were two options for plate movement. Either they moved apart suddenly or moved apart gradually. We're going to try and answer this question, how the South America plate and African plate move. Remember to be looking for evidence for either claim as we learn more about plate boundaries this week. To understand plate boundaries, we need to know what is going on underneath the plates. And before we get into that, let's review a few important facts. Remember, Earth's outer layer is made of a hard, solid rock. Earth's outer layer is also divided into sections called plates. Geologists look for patterns in landforms and in geologic events in order to better understand Earth, and that the plates of Earth's outer layer move. And what was our evidence that plates moved? Earthquakes. So that's where we left off. Plate movement causes earthquakes, but how do Earth plates move? This is the question we're going to investigate today. We will need to gather evidence to let us know what causes Earth plates to move. To do this, we will need to go to the Plate Motion Sim. We're going to be going here to Region 1, this one up here. Remember to pause this video as necessary so that you can get caught up and loaded to where we need to be. The mantle, shown down here in orange, is the layer just below the outer layer. It is between 65 and 100 kilometers below the surface. The mantle is also made of solid rock similar to the outer layer. To give you an idea how deep this is, if you drove the distance from Wilmington to the south part of Orange County straight down into the earth, you would just hit the top of the mantle. Everything on your way would be the surface and the outer layer. On the model here, there's a slider that you can control that allows you to change the hardness of the mantle. The default right now is under soft solid, but you can change this as you go through the simulator. For the simulator, what I want you to do today is to press run to see how the plates move with the soft solid mantle. Once the run has completed and ended, go ahead and click build in the top left corner again and slide the mantle scale to a hard solid. Click run again and note how the plates move this time. Remember, the green line represents where the plate boundary is. Pause here to run the simulation. So if you ran the sim correctly, you would see that the plates were moving with the mantle as soft solid rock and did not seem to move at all when the mantle was hard solid rock. That leads us to a question. What do you think the rock in Earth's mantle is like? Is it hard solid rock or soft solid rock, and why do you think that is? As you think about your answer to this question, remember, plates move. And in our simulation model, only one type of rock allowed plate movement. Now that you've solved this, you know that the mantle is a layer of soft, solid rock underneath the Earth's plates. So now that we know what the mantle is made of, what does that mean? What is soft solid rock actually like? And how is it different from hard solid rock? Well, let's think of two items. Silly putty on the left is a soft solid material. As you can see, it can be bent, stretched, moved around, but it's still solid. The cube on the left is a hard solid object. It doesn't stretch or bend without destroying the cube. At this point, I'm going to turn you over to OneNote, where there are two assignments now posted: word relationships and plate motion on other planets. Remember, these assignments are under Plate Motion tab under your name. Please make sure that you follow the directions for each assignment as they will be graded. Remember that if you ever have any questions about the lecture notes or the assignments, please feel free to contact me through one of these three ways: either a message through Schoology, a direct email, or go ahead and leave a comment below on the video here. Remember to like and subscribe so you get notified every time we post a new video with your assignments. Like I said, we're going to be short and easy on here with our lessons, but make sure you take your time to actually do all the work here so you have a great understanding of what's going on. And on that note, that's all we have for today, so I'll see y'all real soon. Thanks all.